So, welcome back everyone. Today we will do Unit 2, Lecture 1. So, in your Unit 2, we have Differential and Integral Calculus. Okay, so we will start today with Differential Calculus. And so, first of all, as you can see in my screen, if you are given a question, okay, first of all, we do it only for real function calculus. Okay, then suppose if you are given a question, suppose f is a real function and in that domain c is a point. So and if you're asked to find the and you're asked to differentiate it, so you have to use the formula f dash x is equal to limit h tends to 0 f of x plus h minus f of x minus h. So this limit exists defined to be the derivative of f. Okay, then we have to look forward towards some of the rules. Okay, I'm showing you the rules, the basic properties, formulas and rules of how to solve any derivatives. So if you are given a question like d of dx, c of fx, as you can see on my screen, then here c, these are constant and we never differentiate if a constant is multiplied with a variable of this x, like with x is the function with respect of which we are finding the differentiation. So we will take out the c and differentiate f of x only, so it will be c f dash x. Now c constant can be anything, 1 2 3 4 10, any constant value. Okay, so but if it happens like we are only told to find the differentiation of the constant itself, like if in this question here it is in this part d of dx, ddx of c of fx. Here we are differentiating with respect to x, but if it had been like c f of y inside and it was asked dd of x, then it would become constant and entire it would have become 0. Okay, so next, this one, no matter whether we add or subtract, the resultant of the entire differentiation will be is equal to the differentiation of the will be equal to the differentiation of the individual functions and their multiplication or addition, whatever the function, whatever it is given in the question. Then ddx of x to the power n, here n comes to the coefficient and it subtracts by 1. Suppose we are having a question like x to the power 10. Okay, here then 10 will be the value of n there, then 10 would come in the coefficient and the answer will be 10x to the power 9. Then as I told in the first part, if c is a constant, then differentiating would result to 0 only. Okay, then when it's multiplied, fg whole dash, well, this is the you know symbol that we have to differentiate. Okay, then what we have to do, this is also called the product rule, and the product rule is also named as a Leibniz rule. Then firstly we have to take one function as constant and differentiate the other one, then adding it, the one which we differentiated the first time will be taken as constant now, and the other one will be differentiated. When it comes to the quotient rule, the denominator will be squared and the numerator, it will be same as product rule, but in place of plus it will be minus. Then comes chain rule. Well, this chain rule is basically done for composite functions. Okay, and let me explain you how to do the chain rule and also log. Okay, explaining you chain rule. Well, this is derivatives of composite functions basically, where we have one function inside another function. So suppose you're given a question like sine, sorry, sine of cos x. Well, I will show you how to solve this later when I will show you the differentiation of the trigonometric and inverse trigonometric functions. But to explain here what is the chain rule, first we will differentiate this one, cos x. Then we will differentiate the entire sum. Sorry, this entire value. So let's move forward. Then some derivatives of trigonometric functions. Like when we differentiate sin x, we get cos x. But when we differentiate cos x, it becomes negative of sin x. Then it is when we differentiate tan x, we get sec square x, and when we differentiate sec x, we get sec x tan x. When we differentiate, well, this CSC x, it is actually written in short form. It is cosec x. Okay, so when we differentiate cosec x, we get minus of cosec x cot x, and when we differentiate cot x, we get minus of cosec square x. Then comes inverse trigonometric functions. Inverse sine inverse x will give 1 by root over 1 minus x square. Then ddx of cos inverse x will give minus of 1 by root over 1 minus x square. Then ddx of tan inverse x will give 1 by 1 plus x square. ddx of sec inverse x will 1 by mod x. Well, this mod basically represents we have to take the positive value. Okay, root over x square minus 1. For cosec inverse x, um, it's same as sec inverse x, just there is a minus value, minus in front. Then for cot inverse x is minus of 1 by 1 plus cot square x. So you can see this, there is some similarity. For sine and cos, it's same, just there is a difference of sign. For tan and cot also same, just there is a minus sign for cot, and for sec and cosec also there is a minus in front in case of cosec inverse x. Then comes logarithmic and exponential. Well, before that, let me first show you some basic properties of log which are often used in while differentiating. Okay, so for well, in when calculus comes, we always take the natural log. Well, in what is the natural log? If the base is e and not 10. Okay, so for natural logarithm ln xy, so we all know the basic properties. When it is ln xy, multiplication in between, then we just add it ln x plus ln y. When then ln x by y is ln x minus ln y. Then ln x to the power y is y comes in front and it's ln x. Ln e to the power z is x, and e to the power ln z is x. And some useful identities for logarithm: ln e will be always be equal to 1, and ln 1 will be equal to 0. Okay, now let me show you. See, as I told, derivatives of common functions, it requires chain rule. Well, this is how you represent it. Fog x, I mean it is f of gx. Okay, you can also represent it using brackets or g of fx. It can be anything. Let's see how to solve a chain rule sum. So this one, what we did just a few minutes back. What is the differentiation of sine x? It's cos x, but and for cos x it's minus sine x. So I told first we have to solve this inner part, this inside value. So firstly, inside value, what will be the value of cos x? It will be minus sine x, minus sine, okay, x, and then this entire one, sine of cos x. So what is the value? What is the differentiation of sine? It's cos x, so it will be cos of cos x. Done. Let's take another sum like sine of bracket. It's log ln x. Okay, wait a minute. So what we learned, the differentiation of ln. So the differentiation of ln x is 1 by x. First we do this. and then the differentiation of sine is cos x. So it will be cos ln x. Well, we can also use products rule, quotients rule in this type of questions. Let's just show you one such sum. Suppose I take sine again and I take it x ln x. Well, it's you can spell it as log x also. So first, as we learned, we have to differentiate this inner part, inner value. So as you can see, here are two terms x and ln x. So you have to use the products rule to products rule. So to differentiate it, and then we have to find the entire outer part. Okay, so let's firstly we'll take one term as constant. Let's take x as constant, and value of ln x, differentiation value of ln x will be 1 by x plus, this time ln x will be constant. So differentiating with respect to x, it will give 1. Then we are done with the inner part. This is ln x basically. Yeah. Now value of sine is cos. Definition of sine is cos. Wait a second, guys. Backend, are you there? The backend is not there. There's a technical glitch. No issues.
Hello?
So then we will write the entire term, outside term, cos of ln x. So we will cut this x and x, and it will be 1 plus ln x cos of x ln x. This can be done more complicated way. More complicated sums can also come. So let's move on to the next part. I think I have explained you the chain rule. Okay, this sum, sine of x cube. Let's show this also. Sine of x cube, and you are told to differentiate with respect to x. First, you have to solve this inner part again. First, it will be 3x square. As we have seen for the rule that ddx of x to the power n is equal to nx to the power n minus 1. So 3 came to the coefficient and 3 minus 1 is 2. Then we will do the differentiation of the outer value, outer function. It is cos of x cube. Okay, so this will be the answer. So this we have to do the chain rule. Okay. Since we are done with chain rule, now we will see the derivative of implicit function. Well, implicit and there are two type of function: explicit function and implicit function. So when a relationship x and y is expressed in a way that it is easy to solve for y, like we were doing till now, okay, they are the explicit function of x, but which are difficult to write as y are the function or the implicit functions. Then comes derivatives of inverse trigonometric functions. Let me show you again the formulas. here here the inverse trigonometric functions again. Just see another time. These six basic formulas are required to solve all the numericals, and you can remember it like in pair, like sine and cos are having same value, same one, just there is a minus in case of cos. Tan and cot, you can also remember it in pair, just there is a minus sign in front of value of cot, and then sec and cosec also same, just there is a minus sign, so there is a difference only. So you can remember it in pairs and the exception of minus. Then comes derivative of exponential and logarithmic functions. Let's see some of the exponential and logarithmic functions. Okay, I have shown you here. Okay, now see, when it is ddx of a to the power x, and a is, it can be anyone, it can be 2 to the power x, it can be even sin y to the power x, anything. Okay, 10 to the power x, 10y to the power x, anything, 10z to the power x. Okay, then what will be the answer? It will be a to the power x ln a. Suppose in place of a it's e, what will happen? E to the power x, so e to the power x ln e, and we all know the value of ln e is 1. Hence you can say this is a basic formula, and this ddx of e to the power x is just the derivation of ddx of a to the power x. Then thirdly, ddx of ln x is equal to 1 by x. Then these are similar. The ddx of ln mod x is equal to 1 by x. The ddx of log x base a, well, this is not the natural log, this is having a separate one, and this 1 by x ln a. Okay, let's just solve sums here. Okay, let's take the sums of these notes only. E to the power minus x, what will be e to the power minus x? Just showing you. E to the power minus x, so the coefficient of x is -1, so first it will be a minus e to the power minus x. Done. Then like some like this comes e to the power sine inverse x, or e to the power x is cubed. These are all like, you are using the derivative of exponential and logarithmic functions only, but at the same time you're using the composite rules. Okay, let me show you this log of cos e to the power x. Just see this cos e to the power x. So first you have to solve this one. Sorry, split by cos e to the power x. This will be e to the power x only, and that will be sine of e to the power x. Then we can go to the logarithmic differentiation. I have shown you just now how to do the logarithmic. Well, logarithmic differentiation we have to do like this. When the power y is equal to f of x is equal to u of x to the power v of x, then we will apply log on both the sides. Okay. So it will be like, let me show you. Suppose it's sin x and to the power cos x. So we are applying log on both the sides. So it will be log y is equal to cos x log sin x, and then you have to solve it using see like this one. Differentiate root over x minus 3 into x square plus 4 divided by 3x square plus 4x plus 5. So first you have to y, and you have to apply log on both the sides. So just see here, log y is equal to log of root over this entire value. So what is root over? It is basically to the power half. So half will come in front, and then you have to break it with the using the properties of loss. See how they have broken it. This term multiplies. So as we have read, log of xy is equal to log of x plus log of y, log x plus log y. So here log x minus 3 plus log x square plus 4 minus this one, log of x square plus 4x plus 5. Then using differentiation, then all the properties of differentiation of log, they have solved it. Okay. Then when suppose this, take this example, a to the power x. When y is equal to a to the power x, then log y is equal to x log a. You know why? Apply log on both sides. You have learned that x comes in front and it's log a, just like 2 to the power x 2x to the power x log 2. Basically this is derivation only. You must remember this value always, like when, okay, what is the differentiation of a to the power x? It is x log a. Then x to the power sin x, again you have to apply log here. Log y is equal to, then sin x will come in the coefficient, sin x log x, then it's 1 by y dy by dx sine of 1 by x plus log cos x, log x cos x. Okay, then comes derivatives of functions in parametric forms. Now, what is this parametric form? When you have two functions are given and you have to differentiate with third unknown thing, x is equal to sin t, y is equal to cos t. Okay, then you have to differentiate them individually with respect to t. Okay, and then you have to divide it, like dx dt will be uh, x is equal to sin t. Let's take this example where dx dt will be is equal to cos t, and dy dt will be is equal to minus sin t. Then you have to divide it as dy dx. Okay, and then you will get the answer. Let's take this example. X is equal to 280 square, y is equal to 80 to the power 4. Let's take this example. X is equal to 280 square, 80 to the power 4. Let's see if I'm not wrong. Yeah, I've taken the right question. That's a technical glitch. So it will be the a is a constant, which is 2, so we will take 2a outside, so it will be 480 and dy dt. So 80 to the power 4 will be 480 cube. Then we have to divide it, and answer we will get as t squared. Let's see. Dx, sorry, dy dx is equal to 480 cube divided by 480. These coefficients are cancelled, and the answer will be t square, if I'm not wrong. Yeah. We can take another sum, this one, a cos theta and b cos theta also. Well, you can see like this. When we are differentiating x with respect to theta, it will be dx is equal to minus a sine theta, and for dy, I mean dx d theta is equal to minus a cos minus a sine theta, and this y, dy d theta will be equal to minus b sine theta. Then we will do then we will divide it, dy dx. So the answer will be b by a, and you will get it. Okay, done. Parametric also. Then second order derivative. So what is second order derivative? Second order derivative is nothing. Everything we have learned till now, we will like all the properties of differentiation. We have to just differentiate it for the second time using the same rules. Okay, let me just show you with the last sums only. Let's take it sin x, and we are told to find its dy dx. X y is equal to sin x. It will be equal to cos x, and second order derivative means you have to just differentiate it for the another time, and it is denoted like this. So the derivative of cos x is minus sin x. Okay, so like if we do like this, sine of x plus 2 as as we have learned in the using the chain rule. It will be cos of x plus 2, and differentiate on the inner side, it will get 1 plus 0, so obviously nothing will be there, and this will be the answer for one time differentiating. Well, one time differentiation you can also show as y dash, and y double dash is just two time derivation we are doing, second time derivation we are doing, and it will be same, minus sine plus 2. Okay, another if we take like y is equal to suppose log x. So the first time we will differentiate, we will get it 1 by x, and the next time if we differentiate it, we will use the quotient rule here now, square. So again it will be one constant, so it will be 0 first term minus this one will be 1 minus 1 by x square. So this is how you have to do. Let's just do some more numericals based on chain rule and using the second order derivative. I mean the second order derivative of chain rule. Let's take some sums from here. Let's see. X square plus 3x plus 2. Let's solve this one. X square plus 3x plus 2. Y dash is equal to, first we're differentiating it, so it will be 2x plus 3. When we will differentiate for the second time, 3 is a constant, so it will be 0, and 2x, it will be only 2, because differentiation of x with respect to x will be 1. It will be 2. Let's take a composite function and do its chain. Let's see here. Okay, this one, log of log x. Let's see what it comes out to be. Log of log x. So first it will be log x, and then it here 1x. So this is the first differentiation. The second differentiation will be, second order derivative will be, we will now use the quotient rule. It will be x log x whole square then first term will be 0 as it will be constant because 1 is a constant, minus, then now 1 we will take as a constant and we will differentiate this one. So to differentiate this one, we have to use the product rule again. So how to use the product rule? X constant 1 by x, because differentiation of log x is 1 by x, minus okay log x constant, and differentiation of x is 1 with respect to x. So this will be the answer. Log x minus 1 divided by x log x whole square. So this kind of sums are there. Okay. Okay, so this was all from differentiation, and you will not get anything else than this. And I have completed your syllabus of differentiation of Unit 2, lecture 1. So next class we will learn about integration and end of Unit 2. So thank you everyone. You all can move forward.